Alright, I'm going to go over how we make footprints. So first thing, I'm going to make this footprint, which is a connector. So I'll go into Altium. I have my Explorer pulled up here, which you can find in panels. And in my own dropdown, we can typically use one of these, but these are the models that I've made, and they're all following my same format. So just go into symbols first, and then in here I'm going to create item. I like to create symbol and footprint first, and then create the component. Just copy paste this here, and then I'll just grab this description. So you can throw that there. Upon this, you get this creation screen. So you can see in my other library, there's like a certain format I like to do for connectors. So right now, I'm just going to go ahead and copy one of those. So for connectors, I like to have this blue box, blue infill, and then try not to have any of the pin descriptions showing. So you can see here I have the name shut off since it's just designator. And then I'll just make this real quick. So this one is 12 pins. And I also like to follow the pattern at which it lands, which is following this exact thing. So I'll change the name here real quick. So upon that, this looks like it's good, but one thing we have to change is designator. So typically for connectors, you'll see J. You can find like all the different types of components, but we'll close that, we'll save it to server. Perfect. Now, before I continue on, there's a bunch of other things you have to worry about for, this is just for connectors, obviously. So let me try to find this. You can see this. ICs, I typically like to do this, which is also Altium standard with this maroon box, yellow inside, and then descriptive pins. We use U for these. And then I also have a bunch of standard components. I haven't filled it out fully, but you can see for op amps. So there's certain types of components where you just want to show what the component would look like if you were to draw it out. One of these is an op amp. MOSFET is another one, just like do this. One thing I like to point out for the MOSFET too is that for the pins themselves, we actually use the name, so drain, source, and gate. We'll do this also for diodes, so anode, cathode. Usually people will just do A and K, even though cathode starts with a C in industry. So there's a bunch of different things. I haven't filled this out fully, but anything general, you want to put out the symbol so it's more readable. So like relays, FETs, like I mentioned, BJTs, diodes, op amps, stuff like that. Just anything you've seen in electronics classes. So after we made our symbol here, which has also been saved to server, this is an old one, we're going to go ahead and make the footprint. So the way I have footprint set up, you can see here, it's a very special way. So underneath footprint, so this is like a general category. I have no footprints in this folder, but underneath I have a bunch of subfolders. The letter basically just determines the manufacturer name. The reason I do this is so that we don't have repeated footprints. For example, TI, I don't have any TI parts here. I have one TI part here. This is a very general footprint, right? This is SOT23. TI has a bunch of different components with the same type of footprint. There's no reason to make a new footprint for every single one, considering the fact that TI is the manufacturer, so they will all be the same. So I like to do this based off if it's a chip that has a general footprint name, we do this. Obviously for the other ones, not quite as able to. Like this one, this is a very general footprint name. I'm sure I have a bunch of other examples. And then also any chip components, so RLC components, you can use 0805, 0603. Also very general, same. I like to keep them similar across the board so we don't have a bunch of different manufacturers. Yeah, so let's make the T connectivity connector. So we'll create a new item, TE, and then I'll just use the same things here. So upon creation, we have this thing. I'll walk through the entire creation, but an easy way to get started is to actually download the thing first. So taking this part number, we can go here. You can see I already started with this. On DigiKey, they'll have models. Mauser will also have the models. We can go ahead and download, select download format. It'll give you a nice zip file, and then what I do in Altium is I'll open up this thing. So you can see here, download this thing, I already extracted it, and you could just choose one of these. So I don't like to use their schematic lib because it's not as standardized as what I have, but for PCB lib, we'll make some changes to it. So opening this, we get this thing. First thing I like to do is just straight up copy it. So edit, copy component, and then go into here, edit, paste component. So now I'm going to start to create the footprints. First thing I like to do is void all of these different mechanical layers that they have. It's very different across everything, so I might want standard. So I'll add component layer pair for 4 and 5. We'll have the courtyard. So that'll be top and bottom. We keep them as a component layer pair, and then we'll do the next one. 6 and 7. This one is 3D body. And then the final one is coding. So this one doesn't matter as much since we're too broke to do pay for conformal coding, but this is like a polymer layer, so you can show I want conformal coding here, I want staking here, stuff like that. So now that we have all that set up, we can start converting. So hold on, let me enable all these mechanical layers first. I think this also has, okay, it doesn't have the 3D model imported, so we'll have to add that ourselves. So first up, I'm just going to delete some things. So this looks like a good replacement for the top courtyard. So I'm just going to go ahead and switch that layer to top courtyard. Some things, this is just my general format that I've kept consistent, but I do 0.5 millimeter thickness, which is about 2 mil. This designator thing is good, but I'm going to place it on the top courtyard layer. So placing this, I'll make this directive dot designator. So this is really useful if you're doing any pick and place stuff. So technically not good for us, but good for your future if you want to learn and do this in companies. This is the font I use, Arial rounded empty bold. And then I typically do 1 millimeter. Then I'll center it and then place it at 0, 0. Where 0, 0 is kind of depends on the component you're making. So for SMD components, I typically have it at the center of the component, and then for connectors or anything through hole, I have it at pin 1. So we have dot designator there, and then I also like to place a cross there just so more things for this. So 0.5 millimeters, and then this I'll make 1 millimeter in length. I'll just copy this, and then we'll move that to the center. Perfect. So that's that designator set up well. Let me remove some of these other things that don't matter too much. Like this. Don't care too much about that. Alright, I'll keep this silk screen. I think that's fine. Next thing I'll make is, so typically on pin 1, we like to have it show up as a square just so it's easier. So go here, I like to make them rounded rectangles rather than squares. We'll keep the middle hole round, just because it's the hole. And then on here, for corner radius, I typically just do 25%. So that looks good. Good practice is to double check the hole size with the data sheet just so you don't have any mess ups. But it doesn't matter too much. And then next thing, I'll add a silkscreen directive so we know where pin 1 is. So I like to do period. And then make this true type. Once again, Arial rounded. I make this 3 millimeters. You can put it here, wherever you want. So it's typically good. Next thing we'll do is the 3D body. So let me find that layer. Top 3D body. Alright. So model download. And then I'll just download the CAD model. I have to log in. Goodness. Okay. Now I'm going to save this. And now we'll place 3D body. Alright. So here, 3D. Just place a step. And just like ballpark it for now, we'll go into 3D mode and actually place it. As you can see here, it is definitely messed up. So on Z, we have to change our standoff height. Just go with 565 is fine. And then Next up, I like to place it underneath view. It's a little easier for me to align my pin. That looks close enough. Go back into 2D mode. So this is now placed, which is perfect. And then the final step is polymeric, so we'll go to top coating. So coating, much like solder mask and paste mask, is a negative layer, so wherever we place it means we do not want coating there. So I'm just going to go and place a fill. We could technically go with the full, I'll do it the size of the 3D body. And perfect, that's top coating. Also, I'm realizing, okay, yeah. Perfect, that is your complete footprint now. All the pins should be mapped. We might get an error for this since it's just a hole and we don't have that pin. Let's see. Let me make that component. Okay, perfect, we were able to make that footprint. We'll go back to Explorer. And now we'll make our component. So in here, we have just general sort of categories, create component. So now I'm going to paste the old part number. So I'm just going to select this. Usually it'll come up with a bunch of things to paste in. If there's any models, make sure to deselect them because we made our own. I'll just let it import. It'll do this weird thing where it switches the pin. I just switch the name right back. Now I add symbols and footprint. So symbol, we just made, which I believe is this one. Yeah. Then I'll add the footprint. Shows NTN connectivity. Cool. And you can easily edit these by clicking this button, so you can like, oh look, yeah, view this. Which I do now realize, it does seem like there's an error with the pin format. You take a look here. Interesting, okay. So it changes based on who made it. We're gonna follow the one we have in, we'll look at their data sheet and make a decision off that. 1, 2, 3, 4, 5, 6. Okay, so they do it the way we have it. So we're gonna go ahead and go into Altium and change the numbering in the footprint. So typically you want to check this while you're making the footprint instead of after, but we ball 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, we're perfect. Perfect. And now everything is typically good. You can usually try and go through and fill some of these out. But it's not too necessary. It'll be definitely more necessary in a professional workplace. We're gonna get an error here because, oh, revision update. We'll actually change that real quick. Update the latest. Update the latest. Just make sure this is correct one more time. Alright, we're good. Okay, now we're gonna save. Okay, and now that is your fully created component. So if we're in connectors, we can see here, and just quick example, I'll place it here. The components should just be able to search it up. Grab it, place it here. Oops. Alright, I'm going to annotate this, and then we'll be able to see it pop up. PCB. You can see it pop up here, the 3D model and everything. So that's how you make a component.